To reach its 2047 macroeconomic targets, India requires its manufacturing sector to break out of its historical baseline of contributing 15 to 17% of national GDP and reach a sustained 25%. The current industrial momentum, the business-as-usual trajectory, puts that contribution at $2.3 trillion by the target year. This chart tracks projected manufacturing GDP. The top line represents the target vision, culminating at $7.4 trillion. The distance between that goal and the current trajectory leaves a mathematical deficit of $5.1 trillion. Closing this gap requires an acceleration that traditional economic levers cannot sustain. Incremental efficiency and cheap labor arbitrage lack the velocity to bridge this shortfall. Solving this equation requires a transition to advanced manufacturing, governed by a rigid framework that dictates where national capital is allocated based on specific data-driven outcomes. Exponential economic growth relies on a specific metric, total factor productivity. It measures how efficiently capital and labor are combined to generate output. Historically, applying subsidies uniformly across the entire industrial landscape dilutes that capital. Spreading resources thin ensures that no single sector achieves the density required to compete on a global scale. This broad-based approach leaves the current ecosystem with structural vulnerabilities. Supply chains remain fragmented, automation is deployed in isolated pockets rather than continuous networks, and unified infrastructure is absent. To maximize total factor productivity, the state must transition away from uniform support. The system requires an algorithmic filter to identify and isolate only the sectors with the highest potential for impact. That algorithmic filter takes the form of a multi-criteria decision framework, a precise evaluation matrix designed to process the nation's entire industrial base. This framework breaks down into specific parameters. The first dimension calculates economic impact, weighting factors like gross value addition and domestic industry size. The second dimension evaluates strategic alignment, measuring integration into global value chains and capacity for intellectual property ownership. By scoring every industry against these two strict weighted dimensions, policymakers can plot the entire manufacturing economy onto a single priority matrix. This scatterplot reveals the results of that filtration. The highest scoring sectors populate the top-tier quadrants, categorizing them as drivers or pioneers. Only 13 high-impact sectors survive, isolating industries like pharmaceuticals, auto components, aerospace, and semiconductors as the primary engines for future growth. This framework establishes a quantitative foundation for national resource deployment, replacing subjective prioritization with data-driven performance scores. But 13 isolated sectors still present a bottleneck. Operating independently, they lack the sheer mass required to exert leverage on the global market. The structural solution is consolidation. The framework groups these distinct sectors together based on shared operating models and overlapping customer segments. This diagram illustrates that consolidation. The 13 independent industries are structurally merged into 5 highly synergistic core clusters. Categories like engineering and life sciences operate as unified ecosystems with shared infrastructural requirements. This architecture stops the state from fragmenting its research and development budgets. It allows policymakers to deploy sweeping interventions that cascade across deeply connected supply chains. This clustering strategy consolidates fragmented industries into integrated blocks with the mass required to integrate into the highest levels of the global value chain. With the industrial clusters established, the system requires a central technological orchestration layer to force total factor productivity upward. The global technology landscape is dense, with at least 16 distinct frontier technologies competing for state backing and capital investment. The decision matrix is reapplied as a strict filter. 16 vectors are measured on feasibility, readiness, and impact. Only 4 vectors pass the threshold: artificial intelligence, advanced materials, digital twins, and robotics. Restricting state focus entirely to these 4 domains eliminates experimental drift. It ensures deep technological interoperability across all 5 of the manufacturing clusters. Theoretical architecture only matters when it translates to the factory floor. The strategy defines these physical executions as frontier pathways. The artificial intelligence pathway moves production past isolated, localized automation. It designs autonomous, agentic ecosystems capable of making independent, real-time decisions across the entire supply chain. In regulated sectors like pharmaceuticals, autonomous batch release agents continuously scan data. They verify real-time compliance, clearing products for market faster than human supervision allows. The advanced materials pathway forces a transition away from conventional metals. Defense and aerospace clusters pivot to high-strength, multifunctional composites that offer superior thermal and structural properties. In food processing, manufacturers deploy bioengineered films mimicking industrial plastics. They are fully compostable, instantly aligning with strict global environmental standards. The implementation of these pathways allows for the delivery of high-value engineered solutions rather than basic product components. Refusing to adopt this rigid architectural blueprint carries immediate and severe systemic risk. Maintaining the current business-as-usual trajectory leads to a near-term penalty of roughly $270 billion in lost manufacturing GDP by 2035. That failure compounds. By 2047, the mathematical deficit expands to a loss of $1 trillion. The monetary loss is paired with structural vulnerability. It leaves the economy exposed to external supply shocks and cements a permanent reliance on foreign intellectual property. Executing this blueprint provides the structural foundation for sovereign defense and long-term national resilience. In previous decades, the global market prioritized India as a location for cost-efficient labor. The 2047 vision requires the country to operate as an innovation-led powerhouse at the center of global trade. Getting there requires executing an engineered formula, isolating 13 specific sectors, consolidating them into 5 synergistic clusters, and hardwiring them with 4 mandatory frontier technologies. Following this specific architecture pulls domestic firms up the value ladder, facilitating their deep integration into global value chains. It replaces the era of fragmented, localized experimentation with a coordinated, nationwide technological transformation. By treating industrial policy as a rigorous architecture, the $5.1 trillion deficit becomes an actionable and